plenty of kitchen nightmares to know that.
I've had plenty of restaurant jobs too, and I'm just not a big fan of eating at restaurants either.
That's true when
like
you're
putting your lips on their cups and stuff and using their silverware. I don't know. This one time I worked at this breakfast restaurant, and this female cook, she gives me this omelet, and it's like on this disgusting plate, and I'm like, I can't serve this. And I look back, she has this dirty towel, and she's wiping this plate with this towel, and I threw it in the trash and like remake it now. I'm like, that's so gross. I couldn't even. Ugh. Who knows where that towel's been?
Well, she knows where that towel's been.
Exactly.
but not telling.
She doesn't care, but she knows.
It's so gross.
But not telling. All right, it is time. So let's go. Let's go. I wonder when they will buy me one of those really cool microphones, that goes around the head and has a mic extending out.
Walk out here like Bill Gates.
Or Lady Gaga. One of my students actually recorded and extracted all the clips of me, chuckling and laughing, and
Is it
and
available online?
Huh?
Is it available online?
No, he wrote an app around it.
Oh.
What?
Yeah, he actually wrote an app around it. So depending on how you interact with the app, it will give you a different tax, sound effect.
That's hilarious.
Well, I'm not famous enough to trademark my
Your
sound.
laughter.
Yeah. All right. So what we'll do today is to take a look at the practice test. Okay, so this is going to be pretty important because we have some concepts that we have already covered, but this will be the first time that you see certain combinations of the concepts. So that's why this practice exam is kind of important, because I'm kind of just going over questions on one hand, but on the other hand, I'm also kind of telling you guys how to look at combinations of concepts that we have already been exposed to. Everything is here under final exam. There's a practice, and there's a practice with zip in parentheses. If you're using Windows, you probably want to get the one in zip, because the other one is a tar.gc file, which Windows does not natively know how to open. And they contain slightly different files, because the tar file is the original one. The other one does have notes that I have already typed from the morning class. Okay, and I will do another one for this class, just so that you guys have your own version of that. Okay, so the practice test has 6 files. I was only able to get to question number 5 in the previous class, so I think unless I can go a lot faster in this session, it's going to be about the same. So the other 2 will be explained in a different video that I will upload separately. All right. So the folder has several CPP files. You can pretty much, for the most part, ignore the non-CPP files. They're just executable or object files that I needed when I was testing it. And here comes the first question. So every question looks like this. Okay, every question is a program, and at the end of the program, there's some text that describes what you have to do. Okay, what question you have to answer. So for this particular one, if you go all the way to the bottom here, here's the question. So the question is, let me fix the typo first. There's one little typo here. Okay, just so that it's easier to read like that. Okay, there we go. So the question is, if the input in standard input file is ABC followed by a line P character, which is pressing the enter key on the keyboard, what is the output of this program? That's the first part of the question. Second one is, what if the input is CBA? What is the output of the program? The third one is, what if ASDF, just the first 4 keys on the left-hand side, is the input? What is the output? And the last one is, knowing this is the actual output of the program, what is one of the possible inputs that can cause that as the output? So it's kind of asking the reverse question, because we are observing the output of the program and trying to figure out backward of what kind of input can create an output like that. Okay, so that's the format of the questions for this particular one. So now we have to go back and actually read the program. Main is the entry point of everything, so we should start with main. There's nothing really too interesting at main, because the first thing is we have line as an array of 81 characters, and then we have a get line to read in one line from standard input file. We are going to read it into line as an array of characters. Size of line is basically just reporting back how many bytes did we allocate in line as a variable, as an array. And \n is the line feed character. This is what we're going to use to indicate the end of a line. Okay? You don't have to worry about cases where we overflow a line, because that's actually a pretty complicated thing to deal with, because all of the test cases will give you less than 80 characters. So we don't have to worry about, oh, but what if that line has more than 80 characters? Nope, not going to happen with the test cases that you're presented with. The first line of the output is controlled by lines 28 and line 29 of the source code. The first part is really just saying, okay, let's just print process returns. Process, by the way, is the name of the subroutine. It returns a particular value. This is the actual call to process with two parameters. So whatever process returns is going to be printed right after process returns in double quotes. And then the next line, line 29, simply says, okay, let's also print an end of line. The second line is processed line is as follows. In other words, I'm going to indicate the result of the processing of line as an array of characters. The third line is the actual output, is the actual result of line after we process it. Are there any questions about main? We input something into line as an array of characters. We do some processing. We indicate what is the return value of process, and then we print out line after it is processed. So that's the entire main program. Yep, go ahead.
The size of function, is that the number of bytes? Is that?
That's just number of bytes,
Okay.
yes. It is always measured in bytes, size of.
All right.
All right, so the magic, okay, is actually in the subroutine process. So now we go to process and try to figure out what it's doing. So this is process, and pretty much that's the one thing that you have to analyze is the subroutine process. So what we want to do is to analyze what process is going to do. And by the way, the exam is paper only, so you cannot just type the program in and run it and find out what it's going to do. So we have to actually figure this out by hand. All right, so we have two local variables. One is I and one is result. We have two parameters. Buffer is a pointer to a character, and n is an integer. Okay, so those are the four things that we can work with inside the subroutine process. Result is initialized to 1. And the only thing you can do in a loop is to overwrite that 1 with a 0. But once you overwrite result with a 0, it will never return back into a 1. Okay, so you kind of want to keep that in mind. The return statement is returning just result itself. So that means the return value of process can be 1 if we never get to this line at all, or it can be 0 if we ever get to line 18, even once. Then result will be 0. Are there any questions regarding result? Okay. So if there are no questions about result, let's go ahead and try to interpret what the for loop is about. With this for loop, the only initialization is to initialize I to 0. So we're starting from the beginning of the array. This condition is basically asking, is it an empty string? Because, well, at least initially, is it an empty string? It's basically asking, are we seeing the end of a string? Is the element of index I the end of the string, because it is a null terminator? If it is not, then we'll check the other condition. So if the character that we're looking at is not the end of a string, and the character next to it is also not the end of a string, and where we are in this array at this point is not at the end, is less than n, then we will keep processing. Is that okay so far? Okay. So n in this case, in this particular program, never really is not important, because n is 81 in all cases. and the strings are all much shorter than 81. So we never really get even close to n. This is the post operation. We're just adding 1 to I as a post operation. So we're basically just scanning through the whole array, and we stop as soon as we see a null terminator. Are we doing okay so far? Analyzing just the first part of the loop. Okay. And then for each iteration, this is what we're going to do. For each iteration, we have a conditional statement to evaluate. The condition of the conditional statement is just saying if the character that I'm looking at index I is greater than the character at index I plus 1, then we got something to do. Otherwise, there's no else corresponding to this if, so otherwise there's nothing to do for this iteration. We just move ahead. So let's find out what is inside the conditional statement. The then branch of the conditional statement has one local variable t, and let's see if you guys recognize what these 3 lines are doing collectively.
Swapping.
Swapping, and what are we swapping with what?
What's in buffer I with what's or putting what's in buffer I to I plus 1?
Yep, exactly. So you're absolutely right. We are swapping the content or the characters at index I with the character at index I plus 1 of the array buffer. Are we doing okay so far with this code? Okay, so that's the swap code. So we're exchanging something if they're out of order, basically. Okay, because out of order means a character has an ASCII code that is greater than the ASCII code of the next character. Then it's considered out of order, and if it's out of order, we exchange. And also we remember that we have at least one exchange, and as a result, the variable result becomes 0. Are we doing okay so far with this code? Okay. All right. So let's try to kind of imagine what this is going to do when we have A, B, C in the array buffer. Okay. So what I'll do is on the side here, I'll use a text editor to kind of look at the characters here. So we have A, B, C, and it's terminated by a null character like that. Okay. In the first iteration, I is 0. When I is 0, we'll be looking at this as buffer bracket I, and we'll be looking at this as a buffer bracket I plus 1. Is A greater than B?
No.
The ASCII code. It's not. Okay, it is actually less than B, so the then branch is not going to execute, so we are not doing anything at all. Then we look at B and C. First of all, I forgot this part earlier. First of all, is any one of these 2 characters the null terminator?
No.
Nope. So that means this condition is met. Okay, the first part here, this condition is now met. And is 1, because I has a value of 1 at this point, is 2 less than 81?
Yes.
Yep. Okay, so the third condition is also met. So now we have to go into the body of the conditional statement. So now we are looking at line 11. Is the ASCII code of B greater than the ASCII code of C? Nope. So we got nothing to do. Okay. So I is now incremented to 2. We go back to reevaluate this part. Is buffer bracket 2 different from 0? The answer is yes, it is, because we are looking. This is bracket 0. This is bracket 1, and this is bracket 2. I is 2 at this point. Okay. So buffer bracket I is different from 0 is true. Then we evaluate the other one. Is buffer bracket I plus 1 different from 0? That is false, because I is 2 at this point, I plus 1 is 3. Buffer bracket buffer bracket 3 is referring to the 4th element, which is the null terminator. The null terminator is 0. 0 is different from 0 is false. We get out of the loop. So when we get out of the loop, what is result? No, the variable result. It will still be 1 because we didn't get a chance to get into the then branch of the conditional statement. So the return value is going to be 1. And what happened to buffer? Nothing. Nothing happened, right? because we never got into the then branch of the conditional statement. So to answer the question here, for the first one, process is going to return 1, and the process line is going to be just ABC all by itself. And if you want to specify \n, because it does print end of line, that would be fine too. But it's kind of optional. That's not really the most important part of the question. Okay, second one, the second test case is this is your input, CBA, and then the carriage return on the keyboard. So let's go ahead and process that. So we start with CBA and a null terminator. In the first iteration, when I is 0, we'll be comparing C with B. Is the letter C greater than the letter B?
Yes.
It is. So we go through the then branch of the conditional statement. The then branch of the conditional statement will exchange those two characters. So C and B will exchange their positions. So the string or buffer becomes BCA after the first part of the then branch. What happens to result?
Yeah, you changed that. That should be
Zero.
N, right?
Huh?
Shouldn't that be N, not 0? You said the input string didn't have a null terminator, it had a blue line.
Correct. But by the time it is stored in buffer, it has a null terminator. Because get line will get everything up to the line feed character,
And then insert.
and it will only store the portion excluding the line feed character into the string. And then it will also make sure the string itself is null terminated. And that's why BCA and the null terminator is what we should see in buffer when we are done with get line.
Okay, so whenever we go to process this code, the string will always have a null terminator after the last. Well, they'll always be null terminated.
It will always be null terminated. Correct. Yep. All right. So this is after the first iteration of the loop. In the second iteration of the loop, we'll be looking at this is at bracket I, and this is at bracket I plus 1. Is C greater than A? It is, so we're going to go through the then branch again. So that means, the A and the C will exchange their positions. It becomes B, A, C, and then we have a null terminator. This is after the second iteration. In the third iteration, we will start with I being 2, which is looking at the letter C. But because the letter or the character right next to it is a null terminator, that means this condition, this one here, buffer bracket I plus 1 close bracket does not equal to 0, that will return false, which means the entire conjunction will return false, and then we'll get out. And when we get out, what is result? It's going to be 0, because this time we did get into the then branch of the conditional statement. So the subroutine is going to return a value of 0, and line becomes BAC. So when we get to the question here, we'll say process as a subroutine is going to return 0, and then the process line is going to be BAC, like so. Any questions about this? No questions? Okay, the next one is ASDF as the input. So we'll try to figure out what that's going to do. Okay, ASDF, and then a null terminator. In the first iteration, we're comparing A with S. Is A greater than S?
No.
Nope. So nothing happens. Nothing happens to result either. That's after the first iteration. In the second iteration, we'll be comparing the letter lowercase s with lowercase d. Is lowercase s greater than lowercase d?
Yes.
Yes. So we'll do the exchange, which means it becomes ADSF, and result is now 0. It will remain 0, after this. Doesn't matter what happens. It will remain 0. In the third iteration, we'll be comparing s with f. Is s greater than f? Okay. So it will become ADFS and a null terminator. And then at that point, we'll be in our fourth iteration. In the fourth iteration, it will first take a look at S. It is not null, and then we'll look at the next character, which is a null terminator, and that will fail, or it will make this expression return false, and the whole thing returns false. So this will be the result after we call process, And so the answer of the third question is process returns ADFS, and then it returned a 0, and then the process line is ADFS. There we go. Are there any questions about all of these test cases at this point? Yep.
Is the new line is significant in the answer, like it's part of the answer, or
No. Well, you mean for the input part?
Well, no, for when we say process line as
Oh,
follows.
okay. No, it's not. I'm not going to take points off because you did not indicate as an end of line. All right. The last one is actually the most difficult one. But after we process the first 3 test cases, I'm hoping that the last one, it's doable. Because the last one says we got into the then branch at least once. Okay, that's why process returns a 0. But the output is AHDR. Okay, so what can be the input in order to make the output AHDR? That is the question. Okay, so what do you guys think?
We know it has to start with A because.
Well,
I guess it doesn't have to.
It could have started with HA
H. It could have
because
started with H.
everything else is in order, so it basically only made one swap.
That doesn't sound right.
Why do you think it only has one swap?
Because I'm thinking, so when it looks at the first character and say it's H is going to be higher than A. It'll make that swap. Second iteration, it'll be looking at the second index 1, which would be A. And if D is there, then it would switch. Yeah.
Oh, wait.
Alright. Yeah, we would have a problem. But so then where would it switch?
Okay, we know that it got into the then branch at least once. So something got exchanged. Okay?
Okay.
So when something is exchanged, we know that the larger one is now swapped with the earlier one. Okay. So any ideas of how to make that work? The solution may not be unique. Okay. So there may be multiple solutions. You just have to come up with one and say, okay, this will cause the output like that.
I think HDAR.
HDAR. HADR. HADR. Well, let's take a look. Okay, so let's figure out whether that will work or not. HADR. Okay, that's the input. So in the first iteration, it will recognize that H and A are not in the right order. It will swap those two, right? So it becomes AHDR. In the second iteration, it will compare H and D. And once again, they are out of order. So it will swap them, and it becomes ADHR. And then in the third iteration, it will compare these two. They are in the right order, and will not do the compare. But this cannot be the answer because I'm looking at AHDR as the output, and this one will produce an output of ADHR.
So that would have to be our input. What we just came as our output, if that was our input, it would work.
If ADHR is our input, well, if ADHR is the input, it will be its own output because everything is in the right order already. So that won't work either. Yep, go ahead. AHRD will work. Okay. So let's take a look at that one. AHRD as an input. In the first iteration, it will be comparing A and H. They're already in the right order. Nothing happens. So the result of the first iteration is AHRD. Nothing happens. In the second iteration, we'll be comparing H and R. They're also in the right order. Nothing happens. So AHRD will be the output after the second iteration. In the third iteration, it will be comparing R and D. And these two are, in fact, out of order. So it will swap these two. It becomes AHDR. And that's the exact output that we want. The other one that will also work, but it takes a little bit more work, is HARD itself. That will also work.
Funny that you use the word hard.
Yeah, HARD will also work because in the first iteration, it will be comparing H and A. They're out of order. so it becomes AHRD. And once we get to AHRD, kind of know that it's going to work because it will just pick up from the second iteration and work its way to the end. Okay. All right. So that's the one type of question that I will ask you is to present a program, give you certain test cases, and you have to tell me what the program is going to do.
Technically, though, you put the output in here though, because if you put this in here, it would already be in order. It just wouldn't swap anything. Because that would technically be a right answer. Like you could say.
No, but AHDR is going to have a different result because it will swap the H and D because those two are out of order.
Oh, okay, I see.
Yep. All right. Any questions about number 1? No questions? All right. Let's move on to the second one. I'm going a little bit slower today because I had a big lunch. I normally do not have a big lunch, during in the middle of the day. So a lot of energy is now diverted to digestion, yes. My brain is complaining, we need more stuff. But I did drink 1 Mountain Dew, so maybe that will counterbalance it. And I probably need that Mountain Dew to deal with this question. Okay, so this question has its input. If the input is A, B, C, D, E, F with an enter after that, what is the output of this program? Okay, that's just one test case. With this particular program, it doesn't make any difference whether I give you multiple test cases, because once you figure out the first one, the rest will be pretty obvious, okay? But the first one, the only test case, is the one that is kind of like, well, takes a little bit of time to figure it out. All right, so let's start with the main program. The main program has 2 local variables. One is buffer A, which is 81 characters. The other one is buffer B, which is also 81 characters. So no big deal, we know what arrays of characters are. Line 21 is just reading a line from standard input, and I'm presenting the standard input already as A, B, C, D, E, F, and then press the enter key, so we know exactly what is going to go into buffer A. It's going to be A, B, C, D, E, F, and then a null terminator. That's what's going to be in buffer A after line 21. Line 22 is now going to call do something. So the magic, what we are doing, is actually in the subroutine called do something. So then you divert your attention to do something and figure out what it's doing. First thing to notice is it has 2 parameters. One parameter is P1, it is a pointer to a character, which can also be considered as an array of characters, because any pointer can be seen as an array. P2 is also a pointer to a character. This time it's const, simply meaning that I'm not supposed to change whatever P2 points to. That's basically all it's saying. And once again, P2 can be considered an array because it is a pointer of some sort. Okay? So now we proceed to line 5. Line 5 doesn't look too hard. I mean, I'm looking at P2 as an array, and I'm looking at the first element of what P2 points to, and say, is that a 0? Is it a null character? If it is, we'll do one thing. If it is not, we'll do something else. Okay? Then we look at line 7. Line 7 doesn't look too terrible. I mean, we are just copying the first element of P2 as an array to the first element of P1 as an array. Okay? Nothing really too, awful here. Line 11 doesn't look very hot, it looks the same. In fact, line 11 is the same as line 7. Okay? But it is line 12 that is a little bit interesting. Okay? Line 12, once again, is recursive because we are calling do something from within do something. But what makes this one kind of interesting is what we are passing to parameters P1 and P2. Let's take a look at P1 first. Okay? This is P1 as a parameter. What are we passing to it? We are passing the address of the second element of the array P1. Okay. So before we go any further, okay, if it does help, I'm going to put in some extra parentheses just to indicate the order of the operation. So we are basically looking at bracket 1. This is the first operator. We are getting the second element of P1, and then we take the address of that element in P1. Are we doing okay so far? Okay. The other one is kind of the same thing. It's very symmetric. It is just doing to P2 instead of P1. All right. So that is the whole thing. I mean, how do we deal with something like this? Okay. In this class, we have talked about all of these concepts separately. Okay. This is the first time we see all of these things appearing kind of in the same question. Okay. So the way to look at this is to think about it, and think about what an array is, think about what a pointer is, and think about what array indexing is, because those are the key concepts that you have to kind of combine to figure out what this is actually doing. Okay. Well, first of all, the question is, if I have the beginning of the entire array, do I have any way to get to the first and the second element of the array? Okay. So is there an address associated with every element in an array? Okay, everything that we can store to has an address, right? Okay. Is there a relationship between the address of the second element in an array with the address of the first element in an array?
Sure.
Now that really is the key, okay? Because the elements within an array, the addresses of all those elements are contiguous. They must follow in one particular order, and it has to go sequential. Is that okay so far? All right. So those are the concepts that we need in order to understand this. So if P2 is given to me, and I am saying, okay, I'm going to use the address of the second element of P2 to pass to the next invocation, that simply means it's just the next thing, right? It's just the next address. It's the one next to what I was given with. And the same thing applies to this one here. Okay. Are we still doing okay so far? Okay. So what I'll do next is to visualize the execution of this program by tracing it on a piece of paper. So we'll start execution on line 21 of the whole program, which is the get line. And the effect of that is going to be displayed like this. So give me a little moment here. All right, so we got buffer A, bracket 0, and after line 21, that's going to be which letter?
A.
It's going to be A, very good. Buffer A, bracket 1 is going to be
B.
Okay, so I think we get the basic concept, so I'm going to speed up a little bit here. 2, 3, 4, 5, and then the rest will just be C, D, E, F, and then we also have a null terminator after that. A null terminator is just a 0, so I can just do that. Okay. And buffer B is all uninitialized. So buffer B is actually even easier to document because it is all question marks, right? Because it is uninitialized initially, and so we don't know exactly what will be in those particular elements. And I think that's all we need. Okay. So after line 21, this is what buffer A and buffer B should look like. Are there any questions about that? Now, what is after buffer A bracket 6? I don't really care because once we get to the null terminator, that's the end of the string. Okay. Okay. After line 21, we go to line 22. Line 22 is going to do something the first time. So we just say, okay, line 22 calls something, do something, and then we want to indicate what goes into each particular parameter. What goes into parameter P1? The call, go ahead. Buffer B, okay. So this is getting buffer B, and what goes into P2 is buffer A. Okay. That's okay. That is correct. Now we get to line 5. Line 5 is saying, okay, let's look at P2 as an array. What is P2? It is buffer A, and buffer A is referring to the beginning of the entire array. So what is the first element? What is the value of the first element of buffer A? has a lowercase a character in it. Without even looking up an ASCII table, do you think the ASCII code of lowercase a 0?
No.
No, it's not 0. It's non-zero, so that means we have to go to the else, and we continue execution on line 11. So after line 5, we go to line 11, and on line 11, we just do some copying, right? So on line 11, we are looking at lowercase a, which is just this part of the assignment operation, and we have to figure out where it is going. What is the first element of P1 when we look at P1 as an array? That really is the question. P1 is buffer B. It is the address of the entire array buffer B. Buffer B starts here. So where do you think I should put that lowercase a, because I know I'm copying that letter, that character to somewhere?
There.
Right there, right? Okay, so we'll change it to an A. That's easy enough. Line 12 is the one that is kind of problematic. So we have to figure out what we're going to do with line 12. First of all, we have to recognize that line 12 is a call to a subroutine. Okay, we know how to do that. So on line 12, we're going to say, okay, let's go ahead and call do something. Do something. And this is our second invocation to do something. The first one is not done yet, but this is the second time. We're going to pass something to P1. We're going to pass something to P2. The question now is, what are we passing to P1 and what are we passing to P2? Okay, so when you look at the way we pass the parameters, the first parameter looks like this in the original program. And so when you document it, what are you going to do about this? Okay. So if I want to reverse everything to refer to buffer A and buffer B, which address am I passing to P1 in this case?
The address of buffer B.
Okay. Can I say something like that? Would that be correct?
Sure.
Because at this time, P1 is buffer B, and P1 bracket 1 is referring to the second element of what P1 points to, which is also buffer B. And buffer B is right here. The second element of that place is this particular byte here. That byte has a different name, okay? It has a name of buffer B bracket 1. So that's why, I can also express P1, the P1 of the second invocation as the address of buffer B bracket 1, the second character of buffer B. Is that okay? Now this is really kind of the important part, because once we can relate the parameters back to the address of which element in buffer A and buffer B, the rest becomes a lot easier. So it is very critical that we understand how to do this part here and relate P1 and P2 as parameters, as pointers to characters, back to something that we already know, which is array buffer A and the array buffer B. Okay? Now P2 is going to be quite symmetric, because the way I arrange the parameters is pretty much the same thing with P2. So P2 is going to be the address of buffer A bracket 1. The other way to say this is it is the address of the second element of buffer A. Okay, so now we proceed to line 5. Line 5 is saying, okay, is the first element of P2 a null character? Now here we have to be careful. Yep, go ahead.
Can I ask why you decided to make P2 a const, like it's not changeable? Like what difference would it make if it was just a char to a pointer?
Functionally, nothing. But if I make a mistake somewhere within the subroutine and I accidentally have some code that can change whatever P2 points to, the compiler then will catch it and say that, hey, you declare that this is a const char, and yet you're doing something to change it, is not allowed. So it's more like for the compiler to double check my code to make sure that I use the parameter the way it is intended more than anything else. That's a good question. All right, so now we're on to line 5. Now this time, when we get to line 5, you kind of have to read the code first to make sure that we know which element we are referring to. This is referring to the first element of the array starting at P2. Okay? All right. So we look up P2, and P2 says it is the address of the second element of buffer A. The second element of buffer A is right here. So this means that on line 5 of the program, the first element is this guy here. Are we doing okay so far? Okay, because P1 as a pointer can always be interpreted as the beginning of an entire array. So that means there can be multiple names to refer to a particular element, because it can be the first element seen from this perspective, it can be the second element seen by this perspective, and so on. It's basically asking, okay, let me draw a picture, and this way it'll be easy to remember. So let's say we have one house here, one house here, one house here. And this is John's house, this is Joe's house, and this is Jim's house. You can see how much I like the letter J. Okay? So you can say that Jim's house is 2 houses down from Joanne's. You can also say Jim's house is 1 house down from Joe's. You can also say Jim's house is 0 house from Jim's. Are we doing okay so far? And that's the kind of thing that you have to understand when we're tracking down the code of this program. And I drew this with a slope too, because there will be a storm tomorrow. So John is going to be in big trouble. He'll be collecting all the stuff from Joe's house and Jim's house. All right, but is that helping? Is that kind of helping you guys understand why P1 and P2 is sort of floating, okay? And I'm using buffer A and buffer B as an anchor so that we have an absolute reference and say, okay, this is the absolute reference. And if we can relate P1 and P2 back to buffer A and buffer B, then everything is clear. Is that okay? All right. So we're, yep, go ahead.
You're saying P2 0, if it equals 0, it's because the parameters we pass to the
second invocation.
Okay.
Yeah, we're dealing with a second invocation here. In the second invocation, P2 as a parameter is the address of the second element of buffer A. The second element of buffer A is right here. So P2, technically speaking, is looking at this particular place and say, as far as I'm concerned, this is the beginning of an array. Now, if that is the beginning of an array, what is the first element of that array? It's the letter B, right? So now we're comparing the ASCII code of B to 0. Doesn't equal to 0, so we go to the else case, we continue execution on line 11. So on line 11, since we already know what is P2 bracket 0, P1 bracket 0 is kind of the same thing, because we are looking at the address of the second element of buffer B, which is this place here, as the beginning of an array. But what line 11 wants to do is to store something into the first element of this array here, which is referring to this question mark. So that question mark is going to be replaced by the letter B, and then we move on to line 12. Line 12 wants to call do something again. And this time when it calls do something, what is being passed as P1? Let's take a look here, okay? So what is being passed as the P1 of the third invocation of do something is the address of the second element of P1 of the second invocation of do something. Now that is a mouthful.
It is. It's just the third element.
But it is technically correct, okay? Everything is correct the way I say it. I said it. Okay, so let's figure out what that really is, okay? Okay, the second element of array P1 of the second invocation. Yep.
Doesn't it just mean the second element from where we started? So it would just be
It will be the third element of where we started off from. Okay, so this is P1 of the second invocation of do something, and it is the address of the second element of buffer B. All right, so that's the beginning of the entire array, but we don't want the address of the first element, we want the address of the second element. This is the address of the first element, this is the address of the second element. Is that okay? So that means, as far as the third invocation of do something is concerned, parameter P1 is basically the address of buffer B bracket 2. Are we doing okay so far? So using the same type of reasoning, we can now say that P2 is the address of buffer A bracket 2. And it will do the same thing because it's also non-zero, it's non-null because it's the letter C. So we'll end up copying that character over here, and then it will do another recursive call where the P1 will become the address of buffer B bracket 3, and P2 will become the address of buffer A bracket 3, and so on. And eventually it's going to stop. When do you think it's going to stop?
When it gets to the null terminator.
When it encounters the null terminator, it will copy the null terminator and then says, okay, I'm done. And when it's done, is there anything after do something that we are doing in this particular program? Absolutely nothing, right? Because it is the last thing of the else branch, and the conditional statement is the only thing in the subroutine. So there's nothing, absolutely nothing that we do after the recursive call to do something. So what do you think this subroutine is actually doing? It's the same thing as string copy, but in a recursive way.
Once it gets out, though, then it goes to line 23 and it prints buffer B.
Yep. So buffer B will have the same content as buffer A. So we're going to print A, B, C, D, E, F. That's the answer. Sorry? All right. So what I'm going to do is I will switch the order of the questions a little bit because I want to switch to another question that has a. This is question number 2. Okay, the questions are somewhat related. So once you figure out one question, the other questions are somewhat related. So I think it's question number 4 that I want to do it. Okay, let's deal with question number 4 because question number 4 actually, you can see it as related to the first question and also the second question. Okay, so I'll explain why that is the case. With this particular one, you can see there's a lot of blank space here, which is typically a good indicator that you are expected to write some code in that blank space. So the question goes like this, okay? Write the code in is sorted as the name of the subroutine so that the subroutine returns 0 if and only if some characters in buffer, which is the parameter, up to the first null character are not sorted in a non-decreasing order. Well, that is just a mouthful of saying, tell me whether it is sorted or not. Okay? And this particular statement is the same thing, exactly the same thing as the previous one. I just want to be extra clear. Okay? Now, if I did not use the phrase if and only if, then it's not the same thing. Okay? But because I did use the word or the phrase if and only if, that simply means that a 1 or a non-zero is returned if and only if some characters in buffer up to the first null character are all sorted in a non-decreasing order. So is sorted is the proper name of the subroutine because it's just saying, okay, is this array sorted in a non-decreasing way? Is that okay so far? Have we seen anything like that already? Something to do with ordering and remembering whether it's ordered or not? The first problem, right, exactly. But I'm going to pretend as if I have not seen the first problem, okay? So I will work on this one independently. Your code will be graded based on, whether you include, just some minor compile time errors, major compile time error, and also whether the logic is going to work or not, okay? So it's going to be a difficult thing for me to do because it's kind of like grading an English paper. because there's grammar involved and there's also concept involved in this case. Efficiency and elegance are not grading criteria, so do not waste your time trying to optimize the algorithm or thinking, I think there's another way to do this and it's more elegant. No, move on. If you think it works, just move on to the next one. You may assume that buffer as a pointer to a character or an array is properly terminated by a null character, so you don't have to handle the special case of, oh, but what if the string that is passed to me does not have a null terminator? Don't worry about it. We can make the assumption that it is properly terminated. All right, so now that we know what we're supposed to do, let's do it. And we'll do it, basically similar to the first program first. Okay, that's the first way we're going to do it. So the way we're going to do it is to say we'll compare one character in the array with the next one. If we do not spot anything out of order, the whole thing is in the right order. If we spot anything that is out of order, we'll take a note of it and then we'll return a 0 to indicate something in the array is out of order. Is that making sense?
So we don't actually have to switch the order, we just need to check the order.
Exactly, we're just checking whether they are in the right order or not. And that part, I'm glad that you brought up that question, because that's also why the parameter is a const char pointer, because I'm just checking, I'm not changing anything. Okay. Sorry?
I mean, no, just the.
Okay. But I can hear that.
That's the
All right, so what we're going to do is to do it kind of the straightforward way to scan the array. So when we scan the array, we need some kind of index to help us keep track of where are we in the array, which part of the array is already scanned, and what is the next character that we are scanning. I'm going to use I for that purpose, I for index. And we'll start with the first one, which is index 0. And I'm going to write the code in pseudocode first, and then we'll change it to non-pseudocode. So the way we stay in the loop is, or the way we say that we cannot determine, we don't have a conclusion yet, okay, is how do I express that condition that basically says it's not conclusive, I cannot really give you the answer right now.
The character pointed to the I element is not 0.
Okay, so we haven't seen the end of the string yet, okay? All right, that's fine. We'll just spell it out that way, okay? So we'll say end of string not encountered. Is that the only reason why we cannot make any conclusion?
No.
What about the other one?
If that the ith character is less than ith.
Okay, all right, fine. So we'll say, everything is in order so far, okay, up to this point, okay? All right, so that's not a bad starting point. So what I'm doing right now is a general approach of writing programs, okay? So I typically would try to write out the meaning of the code first, what it is trying to do, and then I'll change it into actual code, step by step, okay? All right, so I'm just going to copy and paste it. And then the next question is, how do I capture this thing here, end of string not encountered? Because if I do encounter end of string, I really need to get out, okay, because I'm done. So how do we know that we have not seen the end of the string? And each string is terminated by
0.
a 0, a no terminator, okay? Very good, okay. So that means, if buffer bracket I does not equal to 0, that means what I'm seeing right now is not the end of the string. That's good, all right. So I put this in parentheses because we do have other stuff that we have to deal with. What about the next character? Because even though buffer bracket I let me focus on one character, but looking at one single character, I cannot tell whether it is in order or not, because I have to establish ordering by comparing it to either something before or something after, right? So what about buffer bracket I plus 1? Should I also check whether that one is a null character or not? Yep, I should, because otherwise nothing is less than a null character, so everything is going to be out of order. Okay, so we have to check for that one too, and that's why in the other program, it has a similar construct of comparing not just the one at index I, but also the one at index I plus 1 to check for the null terminator. Okay, all right, so that's fine. That will take care of the first part. End of string is not encountered. What about the other one? Everything up to this point is in order.
Buffer I is less than buffer I plus 1.
Yep, exactly. So buffer bracket I is less than or equal to buffer bracket I plus 1. Now, it is less than or equal to and not just less than because the question specifically said it is in a non-decreasing order, which means I can give you the same letter like A, it is still in order because it's not decreasing. Okay. All right, fine. Looks like we got the condition of the loop all handled. What about the body of the loop, which sometimes can be long and complicated? So what do we do in this case?
All we need to do is have a variable that keeps track of that. So,
You would need to increment I.
Just increment I, exactly. All we have to do is to increment I and say, okay, let's get ready for the next 2 characters to compare. But we are not adding 2 to I, because if I add 2 to I, then I'll be skipping the comparison of one of the pairs of in the array. So you don't want to increment it by 2, only increase by 1. Okay? All right, fine. When I get out, what am I supposed to return? In other words, what is an expression that can tell me that the entire thing is sorted already? How do I confirm that?
so you're not keeping track. You're not keeping track of how big the buffer is.
I'm not keeping track of the variable called result in the other program.
Because I was gonna say, because if you kept track of how long the buffer is, the only way that you only get out of there to return once that failed. Because if that failed, then that means they were out of order, or you reached the end of the string.
Exactly.
So if you kept track of how long the string is, but that's kind of what.
But I don't need to keep track of the length of the string because I is telling me where I am focusing on. Okay? All right, so let's assume the string is not sorted. Okay? If the string is not sorted, that means I'm exiting because this condition becomes false. Is that making any sense? Yep, go ahead.
If I is less than the size of buffer, then that means that the while loop broke somewhere.
Can't do that either. Cannot do size of buffer. The reason why size of doesn't work in this case is because size of is just telling you how many bytes is being used by buffer in this case. Now buffer is technically just a pointer. So as a pointer, it's always taking up 4 bytes with a 32-bit architecture. It's always taking up 8 bytes in a 64-bit architecture. So size of doesn't work in this case because it doesn't have the square brackets with a number inside. So we cannot determine at this point, which is really, so you just highlighted one of the major limitations of array representation in C and C++, which is, once you pass it as a pointer, you lose track of what is the capacity of the array at that point. Okay, so that really doesn't work. Okay, but getting back to what I was talking about a little bit earlier, if I am getting out of the loop because the array has something that is out of order, what can you tell me about that using the conditions that we are seeing here?
Oh,
The last entity failed.
The last one is the only one
That failed.
that will fail, that will return a false, right? Okay. So that's also the same thing as saying if this one is true, that means I got out because of one of these 2. That I saw the end of the entire string. There's nothing else to compare anymore. Is that making any sense?
So you could just return that because they'll return either 0 or 1.
Not exactly that, but a negated version of that, right? So that means, if I want to return a value indicating whether the entire array is sorted or not, I can just return buffer bracket I is 0 or buffer bracket I plus 1 is 0. It has to be an or in this case because they cannot both be 0. There's no guarantee after the null terminator, you will have additional zeros, so it cannot do an AND. It has to be an OR. All right, so this is one way to do it. This is the iterative way to do it. Okay. Now, in question number 2, we learned that we can use recursion, right, to treat a problem as a smaller version of the original problem, but having the same nature, asking the same question. It's just that now it's a smaller problem to solve. Okay, we can do the same thing here. So I'll go ahead and talk about that one after we check and make sure this one works. Some of you will be unlucky and have to take additional classes from me. And one thing that you will learn from me in the other classes is you never take my words. Okay, you always ask me to double check and show you that it does work. Okay, which is something that you should do with all of your classes. Okay, especially with programming where things are really black and white. It either works, it either is or not. Okay. So we'll run Q4 and specify something that is sorted. Okay, ABC is sorted. Comes back and say it's sorted. We will try it again with something that is not sorted and make it really short. Okay, just CB would be fine. It comes back and says not sorted. We'll try some really tricky cases like an empty string. Okay, so by definition, is an empty string sorted? It is. Okay, and we'll try another tricky case where we only have one thing in the array. If you only have one item in the array, is it sorted? It has to be sorted. Okay, works on all cases. So I'm fairly confident this code works. Now we'll go ahead and work with the alternative code to do this. Now this is a trick that I did not really show you guys in this class, but if you want to comment out a chunk of code where you might even have commented within that chunk of code, this works. Okay. And what happens here is with a pound sign at the left-hand side of the entire line, it becomes a C preprocessor command. Okay, and it's not a major useful concept, but it is handy in some cases. If and else and end if works pretty much the same way as what you think they should work. In this case, the condition is 0, which means it is false. So if the condition is true, this is what it's saying is if false is true, we'll go ahead and compile this section of code. Which simply means we're not going to compile that section of code because false can never be true, right? Okay, so that's one quick and easy way to comment out a section of your program without affecting anything else. And I can have commenting inside this chunk of code. It doesn't matter because the C compiler won't even see the actual lines from line 4 to line 14 because the C preprocessor will take it out. The C compiler won't see it. Okay, so now we'll go ahead and implement the alternative version of this. Is sorted const char buffer. Okay, so this time I'll be the super duper lazy subroutine. Okay, in other words, somebody gave me an array to check whether it is sorted or not. I'll do the minimum possible amount of work. That's what I'll do. And I'll be super optimistic and say, maybe that is true. Don't you think if that is true, I have a really easy answer? Okay. And what would be the answer in this case? That it is sorted. Okay. And you can return a 1, a 2, a -5, anything that is non-zero is good. Okay. But sometimes, I might have some extra work to do because I was not given an empty string. Fine. Maybe it is a string of only one character. So the second character of the string that I'm given with is a null terminator. Hey, a function can hope. Okay, fantasize. If that is the case, what should I return? Return a 1, right? Because I have an array of only one character, so it has to be sorted too. Sometimes, fantasies don't work out, and we actually have to do some hard work.
Sometimes.
Sometimes. But maybe, just maybe, it is the minimum amount of work that I have to do to come up with a conclusion, right? So maybe, just maybe, buffer bracket I turns out to be out of order compared to buffer bracket I plus 1. Because that would still be a relatively easy thing to do, right? Because that by itself is out of order. I don't need to look any further. It's out of order already. I'm done. Is that making any sense? Okay. So we turn to 0 here. Sometimes you just have to bite the bullet and actually do the work, right? Except with this subroutine, it's saying, you know what? My time is up. I'm not going to do it. I'll pass it on to the next guy, the next person, the next shift, okay? And say that, you know what? My time is up. I compared this character, the first one of the array that I was given with, and the second one, and I cannot make a conclusion. Maybe you can look at the rest of the array and figure this out, okay? But I'm going to take a nap. Wake me up when you're done.
So you call this one with the address of the next element.
Yes. Like that. So this is how I can relate this particular question to question number 2, which is the recursive version of string copy. This is the recursive version of checking whether an array is sorted or not. But based on the same principle. It's based on the same principle because I am given an array, and the array can have any number of characters. I first check for all the easy cases, okay, where recursion is not needed. I'm given an empty string. The one thing that I'm looking at is the null character. Easy answer. The one thing that I'm looking at is not the null character, but the next thing is the null character. I have an array of only one character. It has to be sorted by definition. Awesome. Easy answer. I look at the two things, okay, the first thing and the second thing, they're out of order. Doesn't matter what is after this because the array has to be out of order because something is out of order already. So the only case that I have to pass it on to somebody to check is this is not out of order. The two characters, the first two characters are not out of order, but the rest may be. Okay. So what you do is you defer that to somebody else and say, hey, I'm going to give you a problem to solve. It is a little bit less complicated than the one that I got because now the first character is not a part of the problem. But starting with the second character of the array that I was given with, you better check this as an array. That is recursion, okay? So recursion is really good when you can break a big problem down into smaller chunks, where each smaller chunk has exactly the same nature as the original program. Yep?
Is it possible to take that second if and toss it as an or into the first, like just to,
oh yeah, absolutely.
because,
Yeah, you can do the or. So you can basically take this condition and put it up here and use an or. Yep. But I was just thinking, in individual cases, which is easier in a way because you're just saying, okay, let's handle the easiest case first. Okay, this is done. What is the next easiest case to handle? Okay, now what is the next easiest case to handle? And we only need recursion for, if all of those conditions fail. Okay. So what we'll do is we'll go ahead and test it, right? Because this doesn't look like it's going to work, but we'll see. Oh, okay, typo. That would make a pretty good question too. Is to have you guys to look for typo mistakes like that. No, I don't think I'll do that. It's a waste of a human neurons. Okay, this is I was not declared. Line 31. That's no I. That's just 0 and 1. That makes this so elegant because you don't have to deal with an index. You're just looking at the first or the second. That's all you're gonna look at, right? All right, let's do that again. Oh, sure. The recursive call. It's just
No, it's just 0 plus 1.
It's just one. It's
Yeah,
the
zero,
second.
yeah, zero.
Yep, you're just saying, treat the second element of my array as your first element, and go do your work. Don't come back until you have the answer. And then what I'll do is what most administrators would do. I'll take your answer and pass it along. All right, so let's try that. Q4, give it a string that is actually sorted. It says it's sorted. Let's give it something that is not sorted. BC is not sorted. Let's give it an empty string. It is sorted. Give it a string of one letter. It is sorted. So all 4 test cases work out too. Now, how can I be sure that if it does work with ABC, it's going to work with ABCD? Because making it one string longer is not going to matter, because and it really helps to look at it in a recursive way, because you can basically say ABCD get reduced to just BCD, and if I already know that ABC is going to work, BCD is going to work as well, so I'm done with that proof. Yeah. When you take CISP 440, we'll work on that sort of stuff a lot. It's called proof by induction. Good stuff.
Are you teaching 440?
I am teaching 440 next semester, and I think nobody else wants it, so I would be the one teaching it. When Fox said, when Professor Fox said that he would be giving out some of the classes that he has been teaching before, I just let Antos and Subsidiary pick their choices first, and then whatever is left on the table, I will take it, no problem. I can. It doesn't matter to me. I like them all. All right, so we're running out of time. As I said a little bit earlier at the beginning of the class, I will make a video out of the other questions. Now, question 3 was covered in the previous class, okay? But I'm going to go over question 3 again in the video, just so that you guys have that also included in the same video. The previous class can just fast forward to question number 5 and number 6. Yep.
Are you gonna make these little trace things for these other ones? The traces that you put over here, like you.
Oh, you mean the text thing
Yeah.
here? I can.
I was gonna say, can you just drop them in Moodle when you're done with it?
Yeah, I'm going to create a zip file out of all the source files that I have worked on already. Because the way I do this may be slightly different from the way I did it in the morning.
It doesn't have to be pretty or anything. It would be nice to be able to have it.
And our final is Wednesday?
I think it's Monday,
Monday?
probably.
I think it's Wednesday. This Wednesday.
Although if that's happiness, then.
So it's not regular time?
It is Wednesday at 12:45.
Wednesday, 12:45?
Yeah.
Thank you.
What time?
12:45.
Is that our time, Professor?
Your time is, it's in the syllabus. I'm just going to look it up.
It is the 17th, 12:45.
I just wanted to show it,
Just in case you want to show it.
just in case.
Wednesday the 18th, though.
So for the late section, the time is from 12:45 to 2:45. So it's just remember, because it's half an hour earlier than the regular class time, so you have to show up at least half an hour earlier. And if you show up even earlier than that, it's even better. It gives you a little bit of time to settle down, spread out all your stuff,
And it's in here, right?
Huh?
It's in here, right?
Yeah, it is in here. Okay, so I got the zip file already done, and I'm going to upload it before I forget.
And you'll post today's lecture on some prof sometime today?
Yes. In fact, if you can do it really fast, I can actually do it now.